I'd like to thank MEP for the invitation to speak today. I'm Carol Sparling. I'm the Technical Director for the consulting arm of the Mammal Research Unit at the University of St Andrews. We've been working collaboratively with developers, with government and academia since 2006, when we first got involved with MCT's CGen project in Northern Ireland. So I won't labour this point, but over the last 5 to 10 years, the UK tidal industry has seen a rapid expansion in terms of devices in the water, at test centres and single demonstrators. The next wave of development are at a scale where things are actually currently starting to get difficult to consent, given the amount of uncertainty that surrounds some of the environmental impacts that have been mentioned earlier. Gareth mentioned the priority impacts for tidal stream energy, in particular being collision risk and collision risk to marine mammals. A lot of these projects, in fact, a lot of the resource, the tidal stream energy resource, is situated in areas that are also important for marine wildlife. So that uncertainty, as I mentioned, leads to difficulty consenting projects. But if we can't consent projects and get them into the water and actually monitor and learn as we do, we can't consent more projects, and that leaves us in this sort of vicious circle. In the UK, we've been trying to progress under a kind of deploy and monitor. Well, Scotland at least has an official survey deploy and monitor policy, where the intention is to start deploying devices and monitoring them to understand the impacts to open up the sort of future pipeline of projects. And Wales are quickly following suit with more proportionate risk-based approach to survey and monitoring requirements for Welsh tidal stream projects. I think Kate Smith is going to mention the recent guidance that we've been working on to that effect later this afternoon. So I'm going to just talk about today just a couple of areas that we've been working on to try and reduce that uncertainty. One is how we improve our prediction of risk, and Gareth mentioned that in terms of the ORGIP priorities. How can we get better at predicting at risk and the consequences of risk, to try and move away from that sort of automatic presumption of impact that Ross mentioned, and that sort of paranoia of the regulators? How can we actually start to gather information to move away from that really kind of paranoid defensive position of the regulators? And the second strand there is the work that we're trying to achieve, monitoring around devices to try and learn and understand, and then feed that knowledge back into our predictions for future projects. So one of the things that we've really been working on, again, it was nice to see fitting under Gareth's priorities for collision risk, is actually developing the tools to understand marine mammal behaviour in tidal stream environments. Until fairly recently, these areas were really relatively understudied compared to other parts of the marine environment, because, as everyone in this room knows, they're particularly challenging places to work. So I'll just highlight a couple of examples here of work in that area. We've been developing a purpose localising array buoy, and what that now enables us to do is actually determine where about in the water column are marine mammals situated, so these echolocating purposes, and actually tell us that the animals are actually spending relatively small amounts of time at the same depth as turbines, and most of the time is actually spent at the surface or foraging on the bottom, and therefore we're moving away from that automatic presumption of these animals are always at risk all the time. Similarly, we're developing methodologies to tag and track animals. We've been doing a lot of strategically funded work in Scotland by Scottish funding from Scottish Government and Scottish Natural Heritage to look at the fine-scale behaviour of seals, tagged seals in tidal environments. And what we're learning there, again, is that risk does really vary over time and over space. And the example up on the screen there is, you probably actually can't see the detail, but that's from a study in Cowray on the west of Scotland that's telling us that seals are actually only there during a very small portion of the tidal cycle, and they're actually only present in that area for the summer. So again, we're reducing our predictions of risk by understanding more about how animals are using the area. And it's an example of actually where we've done that for the Maygen site. Since the original application for consent, the Scottish Government have funded deployment of seal tags, and we've actually measured how animals are using that area. And what we're seeing now is that the animals are actually using the array site much less than previously estimated. So using these data, we've got a collision risk estimate that's a third of the estimate that was used in the consent application. Another area we're looking at is actually trying to understand the consequences of collision. So not making that automatic presumption that every strike is going to end in death. So this is some work that colleagues of mine at SMRU have been doing, where they've been fixing a dummy turbine rotor onto the hull of a boat and driving it at dead seals suspended in the water. And what we're seeing there is that using frozen carcasses, which you'd expect to be more likely to be damaged than fresh carcasses, there's absolutely no evidence of any trauma, any muscle, skeletal, or organ or skin trauma at collisions up to 5.3 meters a second. And what we're looking at now is trying to increase that speed and see if that holds for greater speed. But what we've got there, and what we're actually starting to incorporate into our collision risk models, is this sort of distribution of the probability of mortality, rather than just assuming that every strike ends in death. And then probably arguably more important is actually the learning by doing and monitoring around devices. Faced with a very nervous regulator in Northern Ireland, the CGEM project was only allowed to go ahead under a shutdown. Therefore, there's very limited amount we could learn about near-field behaviour and collision risk in marine mammals. But what we did learn from there is that the operating turbine wasn't a barrier seal that still moved in and out of the channel. And there was also some evidence of small-scale displacement, again, which is good news for collision, and we need to start using these things in our predictions of collision risk at future sites. And moving on to work in Wales, and you heard Martin talk about this earlier, and Chris is going to talk about it later this afternoon. Welsh regulators and nature conservation advisors were able to take a slightly more risk-based approach, and allowed the deployment of the Delta Stream device in a special area of conservation for marine mammals without that shutdown clause, as long as the right kind of monitoring system was in place. And we've been working with TEL since 2011 on the design and implementation of that monitoring system, and we're delighted to be working with them on the analysis of the data that are coming out of it right now. So as Martin mentioned, it's a combination of passive and active acoustic monitoring of marine mammals around the device. And we'll go back a step. And what we're finding from that site, and this is preliminary data, and we're continuing to work this up to ensure that to look and see if this pattern persists. But what we're seeing is that porpoises and dolphins are only ever coming anywhere near the device at slack water. Again, putting a very different perspective on risk than what we previously had.
2 minutes.
Okay. And then I'm just going to finish off here with an example of where we're kind of taking these methodologies, we're developing them further to deploy in the next wave of projects in Scotland. So we're working on a Scottish Government funded project called the Demonstration Strategy, where we're developing and testing these methodologies. And we've developed a technique to track seals in 3 dimensions around turbines using multi-beam sonars. We've also developed improved sonar detection and classification algorithms, therefore reducing the time needed for any sort of post-hoc analyses of those data, and also making an automatic detection system a bit more of a reality in terms of, again, reducing that analysis time, but also potentially in a mitigation situation if that were ever to be required. And so those newly improved and adapted systems and the analysis techniques to deal with the volumes of data are going to be implemented in the next phase of the project, which is the deployment of the monitoring systems at the phase 1 of the MEGEM project in the Inner Sound. So I hope to be back here next year giving you the highlights of the data we've collected there and what we've learned to further our understanding of risk. So watch this space. Thank you.